All right, so imaginary numbers. So what is an imaginary number? So back in Algebra 1, you learned that when you would come up with something like the square root of, let's say, a -4, your teacher would be like, oh, it's a non-real answer, like it's impossible, you can't do it. Well, so now I'm going to tell you that you can do this. There is a definition that says the letter I in math is equal to the square root of -1. So if you were to change this square root of -4 to be this, square root of 4 times the square root of -1. So that's a valid thing, like when you multiply these together, you get that, okay? So the square root of 4 is 2, and the square root of -1 is I, right? So I was created to deal with when you have negatives under the radical, like they just happen in math, and so came up with a way to deal with it. So they're called imaginary numbers, and they're not, they're the opposite of real numbers, right? So there's also another thing that you have here with imaginary numbers, and that's a complex number. So if you take a real number, like let's say 5, and you add or subtract with it, like let's say this 2i that we just got, so plus 2i. So this right here is called a complex number. An imaginary number is when you have just the I part with you. When you have a real part plus or minus an imaginary part, then that's called a complex number. So if you ever hear that term, that's what it is. And so, a complex number could be something like, 6 minus I. That's a complex number because it has a real part and an imaginary part. All right? Okay, so here we go. So you know that the square root of 25 is 5, right? When somebody asks you that, the square root of 36 is 6. The square root of 18, you break it down into 9 times 2, and then 9 is a double 3, right? So it becomes 3 radical 2. Well, the only thing different about having a negative under the radical is now, the square root of 49 is 7, and you just put an I with it, right? The square root of 16 is 4, so you just put a 4i when it's a negative. If you have 20, then you're like, okay, well, 20 is 5 times 4. 4 is double 2's, so it's going to be 2 radical 5, but I put the I with it, right? I don't leave the negative inside. All right, now, there is also powers of I. Now, some of you may not need this, like if you're in regular Algebra 2, but in Honors Algebra 2, we learn this by hand. So we're going to do these over here. So I is the square root of -1. So if you're going to square I, basically what you're doing is you're going to say you have the square root of -1 squared, right? And you know that when you have a square and a square root, they knock each other out. So guess what? The -1 pops out, okay? So we have I is I, nothing else. I squared is -1. Then we come down to I to the third. Well, I to the third, if you follow your exponent rules, I to the third is just going to be I squared times I, right? If you split it up. So that's just going to be -1 times I. So that is -I. And then you have I to the fourth. Well, I to the fourth is, if you break it up, I squared times I squared. Well, that's -1 times -1. So that would be +1. So I to the fourth is +1. Now, here's where it starts getting a little funny. I to the fifth. So could we do this? I to the fifth is just I to the fourth times I. So this is just 1 times I. So that's just I again. So I to the fifth is just I again. I to the sixth, that's I to the fourth times I squared. So that's 1 times -1. So I to the sixth is -1. So do you see this cycle that we have right here, this pattern? Every 4 sets of i's, it just starts to continue again. And so we can kind of tell that I to the 7th is going to, not here, it's going to be that, -I. And then I to the 8th is going to be 1 again. So every 4, it repeats itself. And so let me teach you how to do if you have a higher power. So you have I to the 43rd. So basically what you have to do is you have to memorize these 4. You memorize these 4 right here, and then you know every single answer, okay? All right, let me erase something real quick. Erase that. Okay, you memorize those 4, and then I'll show you how to get every answer. So if you have I to the 43rd, the last multiple of 4 before 43 is I to the 40th. So this would be like saying you have I to the 40th times I to the 3rd. So you know I to the 40th, that's just a bunch of these multiplied together. It's I to the 4th times I to the 4th times I to the 4th, like 10 times. So that's just going to be 1 times 1 times 1 times 1, 10 times, so it's just 1. So this just turns into 1 times I to the 3rd. Well, I to the 3rd is negative I. Okay, so that's what I to the 43rd is. If you have I to the 25th, the last thing that 4 goes into, the last multiple of 4 before 25 is 24. This is like I to the 24th times I. So this just changes into 1, so 1 times I is I. Okay, so I to the 50th. The last thing that 4 goes into of 50 is 48. So this is like I to the 48th times I squared. So this is just 1, because there's a bunch of I to the 4ths multiplied together, a bunch of these 1s multiplied together. And so 1 times I squared, so I squared is negative 1. All right, and this last one, I to the 84th. 84 is literally a multiple of 4. So it's just a bunch of 1s multiplied together, so it's just 1. So all of your answers for your i's always come down to one of these 4 things for any powers of I. Okay. All right. So also with i's, or with imaginary numbers, you have to simplify expressions. But they work just like variables. So like, look down here. I have negative 3 minus 8i. I can drop these parentheses and that doesn't do anything. For this negative, I distribute this. I get plus 2 and then minus 9i. So let's combine like terms. I get negative 3 and positive 2. Those are my real numbers. So put them together, I get negative 1. Then I have negative 8i minus 9i, so minus 17i. So there we go. Over here on letter B, I need to simplify these first. The square root of negative 36 is 6i. You cannot multiply these together without getting rid of the negative, so you have to get the negative out of the radical first. The square root of negative 4 is 2i, and then I have times negative 4i. So here's what I get. I get 12, 6 times 2 is 12. 12 times negative 4 is negative 48. So negative 48, I to the 3rd. And then remember, I to the 3rd is negative I. So I have negative 48 times negative I. So I basically get 48i. Okay. Oh, this last one. Oh, 2 more. So here I'm just going to FOIL this like I would in my factoring video. So 2 times negative 5 is negative 10. 2 times negative 3i is negative 6i. So then I get negative 5i in the middle and positive 3i squared. No, I'm sorry, negative. Right? Because I have a positive times a negative. So negative 3i squared. So let's clean this up. We got negative 10. These can go together and be negative 11i. Now this one here, I got negative 3 times I squared is negative 1. So I really have negative 10 minus 11i plus 3. So I have negative 7 minus 11i when all is said and done. All right, over here I'm going to FOIL again. 6 times 6 is 36. 6 times negative 5i is negative 30i. Now, these are special. Remember, it's kind of like on the last video, I have a plus and a minus of the same thing. So these actually have a special name when you have a plus and a minus of the same thing. These are called conjugates. So when you have a complex number, like let's say you have 3 minus 2i, the conjugate will be 3 plus 2i. You change the sign in the middle, which we'll use in a minute soon. All right, so let's keep multiplying this out. This inside part is positive 30i. And the last part is negative 25i squared. So look, these cancel. Beautiful. So 36. I get minus 25 times, this turns into negative 1, right? I squared is negative 1. So that's 36 plus 25. So what's that? 61. All right. Over here, 5i squared. So I take 5 and square it. That's 25. And then I have I also squared. So 25, this turns into negative 1, so negative 25. And this last part. So division is hardest. You can't really divide these, so what you do, remember when you used to rationalize a denominator? Well, it's kind of similar to that. We're going to multiply by something here. We're going to get rid of the I in the denominator. So to do that, you multiply by the conjugate in the denominator. So 2 minus I, the conjugate is 2 plus I. So whatever you do in the bottom, you do the top. So really you're just multiplying by 1 because 2 plus I divided by 2 plus I is 1. So you're not really changing anything, you're just changing how it looks. So the worst part now is to actually multiply this out. So 3 times 2 is 6, 3 times I, so plus 3i. Then 5 times 2, so plus 10i. And the last part is plus 5i squared. So that's the numerator. The denominator, 2 times 2 is 4. 2 times I would be plus 2i. And negative I times 2 is minus 2i. See those go away? And negative I times I is negative I squared. All right, so look what happens. Bam, these go away. I squared is negative 1. So on the bottom, what I really have is 4 minus negative 1. So I just have 4 plus 1, which is 5. So what's happened here is the denominator has changed into something that does not have an I expression, doesn't have an imaginary part. So that's a 5. At the top, I'm just going to clean up. I got 6.
What?
I'm going to clean up over here. 6. I got plus 13i. And then I have plus 5i squared. So that's plus 5 times negative 1. So really, that's going to be a negative 5. So I have 6 minus 5 is 1, and then plus 13i. So it may not look better, but there is no I in the denominator, and that's the goal. All right, that's it.